Okay, sources of sulfur dioxide. We've already mentioned that you get a little bit, only a little bit, when you have a motor vehicle burning a fuel, and that most of it actually comes from burning coal. Now, why do we burn coal? Well, very little of it is actually to do with industry. We burn coal mostly for electricity. So our biggest source of sulfur dioxide is simply burning coal for electricity in coal-fired power stations.
To generate the energy needed in industrialized societies, vast amounts of coal have been burned. When coal burns, it gives off great quantities of heat energy and smoke. Smokestacks, such as this one, emit so much smoke into the atmosphere that gases in the smoke are changing the very nature of clouds, causing a corrosive form of precipitation known as acid rain. Sulfur dioxide from burning fossil fuels and nitrogen oxides from automobile exhaust fumes react with the water vapor in the atmosphere, producing acidic vapors that mix with the clouds. When the wind blows, these acid-bearing clouds may be moved hundreds of kilometers away from the source of the pollutants. The acid rain that results is damaging to water, forest, and soil resources, and can corrode metals and the surfaces of buildings. One way to address the problem of acid rain is to stop burning high sulfur coal. Coal with less sulfur releases less sulfur dioxide. Another solution is to equip coal-burning power plants with scrubber technology. Scrubbers are placed in the smokestacks and force the sulfur-laden smoke over suspended alkali particles, such as lime. The sulfur oxide reacts with these particles to form an ash that can be removed from the stack as a slurry or powder. Scrubbers can remove up to 95% of sulfur oxides from smoke before it reaches the air.
Okay, so the important point there is, in order to reduce the effect of the production of sulfur dioxide, we can actually react it as it comes out of the smokestack, and that means that we can turn it into, we can neutralize it, because remember, an acidic oxide plus a base is still going to make salt and water. And the base that they're using is called lime, which is actually calcium oxide or calcium hydroxide. So they're using something which is readily available, and it removes the sulfur from the smokestack, and it produces the solid that you found being piled up in that image. Okay, oxides of nitrogen. Again, you do get a certain amount with the electricity supply. You get some from metals, but mostly it's motor vehicles. Motor vehicles are the main source of nitrogen oxides. Although there are some coming off, it depends upon how much coal you burn. It's a small amount of the oxides that come off coal, but if you're burning a lot of coal, that's still going to account for a lot of nitrogen oxides.
The lightning that occurs during thunderstorms brings about the direct union of nitrogen and oxygen in the air to produce small amounts of nitric oxide, as does heating the two elements together. Oxygen and nitrogen from the air react at engine temperature. This makes nitrogen monoxide, which, when it is released into the atmosphere, reacts with more oxygen in the air to form nitrogen dioxide. Acid rain is formed when acidic air pollutants such as sulfur dioxide and nitrogen dioxide dissolve in rainwater.
Okay, so one of the essential points that they made there was that the internal combustion engine provides a spark just like the lightning does. And so you've got air drawn in to burn the fossil fuel that you're trying to burn in your fuel in your engine, and you're providing a spark, and the nitrogen and oxygen will react at the same time. So it's not actually that the nitrogen is inside the fuel, it's that you're creating what's the almost like a mini lightning strike inside the air fuel mix. So if your timing is ever so slightly off, you're going to be reacting a lot more nitrogen oxides. And incidentally, they remove that using a variety of catalysts as well. Okay, so when you look at this, there's forming nitrogen oxide and then forming nitrogen dioxide. Okay, but you also get a large amount of unburnt hydrocarbons when you are accelerating your car. You also get larger amounts of nitrogen oxides being given off. And you notice how they call it oxides of nitrogen? That's because there's more than one main one. All right. Now, when you combine the hydrocarbons that aren't burnt properly and the oxides of nitrogen and ozone, you end up with photochemical smog as well as acid rain. Photochemical smog causes a large number of cities to have a blanket layer over them that looks almost brown. And Los Angeles has it because it exists in a basin. But then Sydney is not without these problems as well. You can see that different places have got different amounts of acid rain. And you can see that Randwick's quite high in the acid rain stakes for the sulfur dioxide. And you could see that if you're looking at Chullora, then that's pretty high out of the suburbs. There's a lot of car fumes out that way. And that was in June 2005, so we're talking about 12 years ago. So in order to reduce the sulfur dioxide and nitrogen oxides, we can reduce the amount of coal being burnt. Well, that can be done by being energy efficient, turning off appliances when we don't need them, get companies to use low sulfur coals. Australia lost a lot of market to China because our coal was far too high in sulfur. Okay, reduce reliance on fossil fuels. So if you've got more things like hydroelectricity or solar power or windmills, then you don't need a fossil fuel to produce your electricity. You've got a lot of smelting that goes on, and that produces sulfur dioxide. But if you use a scrubber, or you can direct it off and try and make it into sulfuric acid, which is one of the things they do, actively make it as a source. Use scrubbers to remove oxides, and you've got catalytic converters that will actually